Okay, everybody, welcome to this one. This is Unit 4, Lesson 4, Parallel Line Construction with Parallel Lines with Multiple Variable Problems. Okay, this just means that we're going to have some problems that are going to have more than just an X in it. Okay, so we're going to take a look at this. Okay, the first thing is that I wanted to show you is how to construct parallel lines. I will demonstrate this in class tomorrow. Okay, so don't worry too much about this. I'm just showing it to you so that you will have opportunity to actually have the instructions. And it'll make more sense once you actually do this with a compass. Okay? So this is what you end up with. Main thing is you're trying to find these 2 points at a certain position, and then once you do that, you just construct the line through it with a straight edge. All right. Okay, so what they want us to do here is they want us to find P, Q, and R if the measure of angle 2 is equal to 6Q plus 5, so that's this one. The measure of angle 1 is equal to 5P plus 6, or minus 16, and measure of angle 5 is 12R minus 1, and the measure of angle 4 is 3P, and measure of angle 6 is 97 degrees, okay? As you can note, we've got all of these things are parallel lines, okay? So this line coming across here, this diagonal, becomes a transversal to both this pair of parallel lines and this pair of parallel lines. So all those angle relationships that we've talked about in the previous 2 sections are coming into play here. Okay, so the first thing they want us to do is to find these things. So angle 1 and angle 4 are alternate interior angles. This one and this one. And angle 1 is defined in terms of P, and angle 4 is defined in terms of P. And since they're alternate interior angles, we know that they are congruent. Okay? So this means we can simply say 5P minus 16 equals 3P. Solve for P by subtracting the 3P from both sides and adding 16 to both sides, which gives us 5P minus 3P equals 16. That gives us 2P is equal to 16, so P is equal to 16 over 2, which is 8. Okay, so there's 1 down. Okay, let's take a look and see what's going on with Q. The measure of angle 2 is the only one that's measured that way. Okay, so let's take a look and see if that's the one they're going to work with first. Okay, so angle 1 and angle 2 are supplemental to angle 6. So this means these 2 angles put together plus this angle are 180 degrees because those are same side interior angles. Okay? So what we do is since we already know what P is, we can go ahead and solve this. So we have the measure of angle 1 plus the measure of angle 2 plus 97 equals 180. So that gives us 5P minus 16 plus 6Q plus 5 plus 97 equals 180. Okay, substitute the 8 in that we found in the previous step for P. So 5 times 8 minus 16 plus 6Q plus 102 equals 180. So this gives us 6Q is equal to all of these numeric terms subtracted from the other side. So 180 minus the 102 minus the 40 minus or plus the 16 is going to give us our answer. Okay, so 6Q is equal to 54. Divide both sides by 6 gives us that Q is equal to 9. Okay, we still need to find R. Okay, so let's see what we can do with that. So angle 5 and angle 2 are congruent, but let's see if there's a better way to do this. Okay? Okay, so the measure of angle 2 is equal to the measure of angle 5, and they are alternate interior angles, and that's the reason they're equal. So we're going to put 6Q plus 5 is equal to 12R minus 1. Q we found out was 9 in the previous step, so 6 times 9 plus 5 equals 12R minus 1. So this gives us 54 plus 5 plus the 1 that we brought over from the other side is equal to 12R. So this gives us 60 is equal to 12R. So divide both sides by 12 gives us that R is equal to 5. Okay, so that gives us that Q is equal to 8, P is equal to 8, Q is equal to 9, and r is equal to 5. Okay, that concludes example 1. So example 2, we've got a triangle and two parallel lines. Each of these sides of the triangle, these two right here, become transversals. So all the angle relationships are true here. So angle 4 is the same as, well, we can't say it's the same as angle 2, but we can say 5 and 1 are the same. And we can say that 6 and 3 are the same. Okay? All right? So let's take a look and see what we get. So angle 3 and angle 6 are the same because they're alternate interior angles. Okay? So let's put that in. So that gives us 11a minus 12 is equal to 3a plus, or 3 plus 8a. Okay? We're going to combine like terms by adding and subtracting. So we're going to add the 12 to both sides and subtract the 8a from both sides. So that gives us 11a minus 8a equals 12 plus 3. So 3a is equal to 15. So a is equal to 5. Okay. Let's go on to the next one. So this gives us what? Angle 6 and angle 7 are supplementary. So we know that a is equal to 5, and measure of angle 7 is in an algebraic term. So let's take a look and see what we can do with that. So we have 3 plus 8a plus 20b minus 3 equals 180. Okay? So what we're going to do here is we're going to substitute the 5 that we found in the previous step for the a. So this gives us 8a plus 20b is equal to 180. And we got that, we're going to divide both sides by 4. Okay? So what they did is these 3's canceled each other out. So we didn't have to worry about those. Okay? So this gives us 2a plus 5b equals 45. Okay? We know that a is 5, so that gives us 2 times 5 plus 5b equals 45. So 10 plus 5b equals 45. We're going to subtract the 10 from both sides. Gives us 5b equals 35. Divide both sides by 5. Gives us that b is equal to 7. And that concludes this lesson. So make sure you come in with any questions you got, put them on the parking lot. I will have 3 questions for you tomorrow when we meet. Thank you very much. Goodbye.